Hello, everyone, and welcome to this discussion. I want us to have a look at how we can operate LED lights by using a digital input sensor device. In this particular case, we're going to use the digital push button as the digital input device. So we will begin by building the circuit. And after we've built the circuit, then we will do the code. So I want to use the Tinkercad environment. So I can come to, once you sign up to Tinkercad and you have your account, you can access your account using the login credentials. Then come to designs. Under designs, when you click on designs, you'll see your designs here. You click create, then you go to circuit, and then give it time to load. Then under circuit here, we search for Arduino. We search for Arduino Uno. We can pick Arduino Uno R3, this one here, put it in the design area. Then we search for a breadboard here. We can go for breadboard small, click it, put it here. Then we connect the positive 5 volts DC here, give it a red color. We come, connect ground here, give it a black color. Then we can loop the power supply to the other side of the breadboard. Connect that there. Pick a red color. Loop this other part here. Then we go back to our library of components and then search for the push button. We can go for this one here. We come and connect it there. Then we search for LED. You can go for this one here. Come, put it here. And then we can go for a resistor. To protect the LED from too much current, can place it somewhere here and then rotate. Then drag it down here. May need to move the push button a bit. Then connect this other leg of the LED through the resistor to digital pin number 13, where the LED is connected to. This confirms that this side of the LED is the anode. This value, I think we can use 1 kilo ohm. Any value between 10 ohms and 1000 ohms will do. Like a typical value is also 220 ohms, will also work here for the LED. Then this other side, we connect to a ground. The cathode of the LED, we can connect to ground in black color. Then the digital push button would require a pull-up resistor. So we can come and connect that one here. The value of the pull-up resistor, we need a considerably high value. So you can put, for example, 10 kilo ohms here. You connect, remember for the push button, the pull-up resistor, we connect it to ground, not to positive VCC. We're connecting it to ground. And then this side, this other leg of the push button, we can connect to VCC. And then we can connect the push button to digital pin number 07. So I can come, maybe pick a different, this one here being for the control, let me give it a different color, like orange. Then choose a different color like purple and connect the push button, the other terminal of the push button, to digital pin number 7. So once we have done the wiring, then, so this is our circuit. This is the Arduino Uno microcontroller. We've tapped the power connections, 5 volts DC and the ground, and looped to the breadboard. And then we've connected the LED cathode to ground, and then the anode through the resistor to digital pin number 13. And then the push button connected this terminal 1A to positive VCC, terminal 2A through a pull-up resistor to ground, and then terminal 2B, I have used it as the output, which is sent to a digital pin number 7. So the value coming from the push button should be in digital form. That is either a high or a low. And it is the one that we want to use to operate the LED. If the value is high, the LED is supposed to turn on. If the value is low, the LED is supposed to go off. Then now we can come here and do the code. So I can change this one to text. I'm being warned here, if at all we want to switch to the text mode, meaning now the blocks will be lost. So we continue. And then I come here, you're coding using C++ language or Arduino language. So I can write my program here quickly. So I can put the first variable, integer variable LED, and assign it digital pin number 13. So in this case, we are connecting the LED to pin number 13. And then we declare another variable and pin initialization for the push button. So for the push button, let's connect it to digital pin number 7. So in this case, we're connecting the push button to digital pin number 7. And then we need another variable to store the value that is coming from the input device, that is the push button. So I can declare a variable, another integer variable here, and call it value, and initialize it to 0. So in this case, we can consider this one as a variable to store the value you can say the red value. So we're done with the pin initializations. Then we can come to the second section of the program, the void setup part. So the void setup part here, we put the section of the code that will be executed once. And so we can put the pin mode definitions. So I can put pin mode. I can set the LED pin. Let's set the LED pin to be the output pin. So let it operate in the output mode. So this one set for us pin 13 as output. Then pin number 7, we want to use it as the input. I can come here and put pin number 7 Pin number 7 is the input. And now we can put here set pin 7 as the input. Set pin 7 as the input. And then I think that one can end for us. The void setup part, then we go to the void loop part, which contains the section of the program that will be executed repeatedly. We can put here. I can assign the value coming from the push button to the variable we had declared. So we can read the push button value using the digital write function. Digital write function. So sorry, let's begin with the digital read. Should be the digital read, because we are reading from the push button. So let me use the digital read function there. We're reading from the push button. So you ensure that that pin is the same variable declared up there. So in this particular case, what we're essentially doing here is we are setting the value equal to the pin 7 value. Then now we can use that value to operate the LED. So I can put now the digital write function here to the pin where the LED is connected, the value. So in this particular case, it means that we are setting LED to the push button value. LED to the push button value. Now, this is now the program. This is the program, so we can emulate. Apologies, there's a small error here. There's a bracket that is missing. We can put that bracket, and then we can start the simulation. Again, a small error here. Can start the simulation. Now our code is okay. So now I can hide the code, come to the circuit here, and then we need to operate the push button. When we press the push button, the LED is coming on, meaning it is receiving a high. When I release it, is going off. Press the push button, the LED is coming on. Release, it is going off. Press, coming on. Release, is going off. Now, it therefore means that if I were to stop the simulation and then I come and duplicate the LED, so I can copy, I put another LED here. Let me put another LED here. And then again, put a third LED. I put a third LED here. Change the color of this LED to green. Change the color of this other LED to yellow. Or let me give it, yes, let me give it yellow. Then I come and wire this leg of the LED, that is the cathode. I connect this one to ground, come and connect this cathode still to ground. And then I come here and pick yellow, still the same signal, or orange, sorry, the same signal. I come and connect it there. Then I come again, the same signal, I come and connect it there. So in this particular case, I've connected a set of 3 LEDs. Maybe I think I can incorporate the resistor. I can incorporate the resistor, so I can copy this. I'll come put a resistor here. I may need to move my LED. Let me delete this connector. Connect the resistor there, and then you can also move this one here to create some space. Move this cable here, then duplicate this resistor. Come and put it. This one I may need to rotate it. You come and put it there. Then now I can pick this one, come with it, change direction, connect it here. Then come pick this one, come with it, tap the same signal. So in this case, I've looped the same signal to a set of 3 LEDs. Now I can start the simulation. So I want us to operate the 3 LEDs using the same digital input device, that is the single push button. So now if we press, we can see now the LEDs are lighting simultaneously with the high. They're lighting simultaneously. So in this case, we're operating 3 LEDs simultaneously with a digital push button using the same code. And of course, we're operating LEDs of different colors. Now, once again, this is our program. We have done pin initializations for the LED, the push button, and we've declared a variable to store the value of the push button for us. Under void setup part, we've utilized the LED pin as the output pin, the push button as input pin, and then we are using the digital read function to assign the value captured from the push button to the variable that we've called value, and then we are using it to operate the LED. Thank you very much for watching. If you have not subscribed to our channel, kindly take a moment and subscribe. Watch for our future videos. Thank you. Bye-bye.